there are students nga asking for kanang extension because nala sila certain nga concerns. So kindly message me, and and then those nga ni message na nako, I cannot answer your questions or your concerns right away kay nasad ko uh, work nga gi get man, so I can entertain you only during class hours na to. Okay, so we don't have any concerns regarding our activity or regarding our classroom, newly established classroom. So we'll proceed now with our discussion.
Okay, sir.
Okay, so we're done with the discussion about beams. So we now proceed with the reinforced concrete slab. So depending on upon how it is reinforced concrete slab is classified into the following types. So there are four types of slab: the one-way solid slab, the two-way solid slab, the rib floor, the flat slab or girderless floor. So for this evening, we'll only discuss the one-way slab. So each type of floor system has its own advantages and application depending upon the following considerations. So number one is the spacing of the column, the magnitude of the loads to be supported, the length of the span, and the cost of the construction. So for the one-way slab is the common type of reinforced concrete floor system made of solid slab supported by two parallel beams. So this type of floor system is adapted when the supporting beams are almost rectangular in floor plan. So you have to remember the distinction between the one-way and the two-way slab. So specifically for one-way slab, the supporting beams are almost rectangular in floor plan. So how do you consider it is a rectangular in floor plan? So you need to divide it by 2. So kung ma-divide mo siya og 2, that is a I mean, if half ang imuhang usa ka side sa imong other side, sa longer side, that is already rectangular. So if it's almost the same size, both sides, that is square na, di ba? So one-way concrete slab is designed by making an imaginary strip of 12 inches or 30 centimeters wide perpendicular with the beam that supports the floor. So upon investigating that it's a one-way concrete slab, you have to put an imaginary line of 30 centimeters wide perpendicular with the beam that supports the floor. So this imaginary strip is considered as a beam is applied where the width is equal to 0.30 meters and the depth is the thickness of the slab. So the depth of the floor is purely dependent upon the span and the magnitude of the superimposed load. So unlike beams and girders, floor slab needs no web reinforcement or stirrups. However, in case of the heavy load where the shearing stress may be greater than the allowable value, the depth of the slab is increased. So for example, look for the concept. So for example, with this one-way slab, just imagine that this is a rectangular no in shape no. Maybe siyang illustration medyo square lang siya tanawon, but this is rectangular in shape. So you have to identify nga ang duha niya ang duha niya ka supporting beams kay kanang nasa taas ug nasa ubos. Not on the right, not on the left, but ang taas ug ang ubos mo na yung supporting beams. The left and right beams are your secondary beams. So ang main nga nag-support ani nga slab is ang top ug ang bottom. So kaning taas ug kaubos mo ni beams nga nag-support sa slab. So that is why as stated there is sa katungyang definition, you need to make an imaginary strip of 13 centimeters wide, perpendicular with the beam that supports the floor. So unsa may perpendicular sa imuhang beam nga supporting beams. So diri sa taas sa ubos gabutang siya og imaginary line nga 30 cm. So kanang 30 cm mo na nag-serve as iyahang beam kintahay sa slab. Aside sa beam nga nag-support nga katong gi-design nato previously, ang slab butangan sa dasya og imaginary na 30 cm line serving as the beam sa slab. So murag og dubli ang iyahang kuan. Dubli ang iyahang sugga support sa slab. So basically, gibutang ka og 30 cm gikan sa face sa imuhang supporting beam. So sa taas na po kay imaginary, sa ubos na po kay imaginary. So as you can see, kaning diri nga nagbend na nagbend diha. So mao na siya point of inflection point. So kana nga point diha ang utlanan sa 30 cm. Kung makita na mo sa taas, makita niyo sa ubos na ay gabawg, di ba? Wag in diagonal. So that's the inflection point. Mao na utlanan sa 0.30 cm, 0.30 meters na imong imaginary line. Diha kutob ang imong imaginary line that serves as your beam. Alright. So nakakuha ra, nakapas ra. You're catching up.
Yes, sir.
So, padayon ta.
Yes, sir.
So let's proceed. So, we have here the minimum slab thickness ratio. So, for simply supported slab, meaning na duha ka supporting a beam, ang ratio nimo na is 1:20. So, on one end, continuous. Sa usa ka end, na kay beam sa usa ka end, continuous ang imong slab is 1/24. On both ends continuous, 1:28, 1/28, and cantilever is 1/10. So how to use this table in determining the minimum slab thickness allowed? Considering the following illustration. No? So kini nga formula it is used to determine kung unsa kabag-a ang imong slab nga gamiton. So for a fully continuous slab resting on a beam spaced at 3.5 meters, determine the minimum thickness of the slab. So sa iyang problem is a fully continuous slab. So there is atong table for a fully continuous slab, which means both ends continuous, is 1/28. So imo na in order to achieve the thickness, so ang imuhang length sa imuhang beam, ang length sa duha ka beam, butangan nimo i-multiply nimo na sa imuhang slab thickness ratio sa both ends continuous, which is 1/28. So it's 350 mm times 1/28. So let's compute. So it's 0.35 times 1/28. The answer is 0.35 now. So 0.35, so 350 mm times 1/28. That is 12.5 cm. So, kan 12.5, that is the thickness of your slab. So, in millimeters, that is 125 millimeters. So, kakuha ra, how to solve the thickness of the slab? Nakapas ra, naka-follow ra.
Yes, sir.
Records lang in centimeters, sir.
Required siya nga in centimeters siya.
It is better if you use millimeters. Actually, ang gagamit niya ni 350 times 1 over 28. 350 is in mm na siya. In kuan na siya, cm na siya. So kung imo ni siyang i-millimeters is 3,500 times 1 over 28. It's 125. 125 mm. Okay, padayon. So for in the placement of reinforcing bars in one-way slab, so the bending moment of the center of a fully continuous slab is said to be equal. So hence, there should be the same quantity of steel reinforcement at the center and both ends of support of the slab. So to have equal amount of steel bars that will resist both the positive and negative bending of the slab, steel reinforcements are bent up alternately at the inflection point equal to 1 over 5 of the span from the face of the supporting beam extended over the support to 1/4 distance of the adjacent span. So like for example, this one. So L is your length. L is the length of your slab from the face of your beam. So as per design, you need to bend up alternately at the inflection point. So asa man imong inflection point? So as I have said earlier, ang inflection point nimo is katong point 30, di ba? Imaginary line nga 30 cm. So katong imaginary line nga 30 cm gi-identify na to dire gi-identify na to dire as L over 5. So katong L over 5, mao na for example, ang imong length sa imong slab is 5 meters. So 5 over 5, that is 1 meter. So that is 1 meter. Mo na point nga mo bend na ka sa imong 3 bars. So mo na gitawag siya nga bend bars. Okay? So makita sa nimo dire ang imong bend bars. Naka-bend siya, that is L over 5 nga portion. Okay, so the remaining straight bars are placed at the bottom of the slab, extended towards the beam to have at least 15 centimeters anchorage on the slab. It's classified as semi-continuous and bending moment is much greater than the continuous span. Some design provides alternate reinforcement placed between bent bars across the supporting beam. Some design provides alternate reinforcement placed between bent bars across the supporting beam. So as you can see, supposedly, ang atuarang reinforcement na is kanang bent bars and the straight bars. So as you can see, naana diha bent bars no, mubawg ka sa point nga L over 5. And then in between the two bent bars naatay straight bars. So you have to remember nga ang bent bar spacing na to is 0.30. You have to take note of that ha. Dili na ako ipakita diri sa PowerPoint, but you have to take note of that. Bent bar spacing is 300 mm. So in between your bent bars, at the bottom of your bent bars, natay straight bars. So the spacing between the bent bars and the straight bars is 0.15, right? So inigabot na po nato sa taas, sa inflection point, as stated here. Some design provides alternate reinforcement between bent bars across the supporting beam. So across the supporting beam ha, so meaning there is a support. So morning natin gitawag nga cut bars. So there is makitaan nyo sa section, ang imuhang inflection point is nasa taas, di ba? So ang bent bars is nimbawag man ka sa taas. So kana diha spacing sa duha ka bent bars, gabutang ka og cut bars. So, pila may spacing sa cut bars. So, the same. In between duha ka bent bars is cut bars. So, since 0.30 ang bent bar as spacing, so ang imong cut bars is in between sa duha ka bent bars. So, that is 0.15 gyapon, the same sa straight bars. Kuha ra?
Yes, sir.
So, makasabta naman tingali sa illustration. Okay.
Straight bars, sir. Kanang straight bars na mo extend po na pareha din ang mga bend bars.
Yes, mag-extend gyapon na asa ang straight bars from its word straight. So if naa kay continuous nga beam on the other side, mula sa gyapon na siya dito. So kung dili na siya continuous, i-terminate na nimo diha sa beam. So as stated here, no siya gibutang dire nga extended over the support to 1/4 distance of the adjacent span. So 1/4 distance of the adjacent span. Pagkat-ani mo na dire sa section, kung ang imuhang rebar is dili na continuous, ang straight bars is dili na continuous, for example, may extend ra ka og pila ganito? 15, di ba? I believe it was 15. Sige. Any questions? So, posita diri sa shrinkage and temperature reinforcement. So, makita na to diri sa ato ang section nga natay gitawag nga temperature bars. So, anything nga perpendicular sa imong straight bars, mo na imong gitawag nga temperature bars. So, the purpose of these temperature bars is to counteract the effect of shrinkage caused by changes in temperature. It serves not only to hold the reinforcement to their designed position, but also distribute possible concentration of loads over a larger area. So, dili man sad pwedeng ang atong straight bars lang sa dagsaligan o katong bent bars. So dapat naate additional nga reinforcement to counteract the effect of shrinkage. So shrinkage kanang mura siya mo shrink ko sa manay pasabot kanang buko na siya due to changes in temperature. So to counteract that, you need to provide temperature bars. So the ACI code on shrinkage and temperature reinforcement states that in no case shall this reinforcement be placed farther apart than 5 times the slab thickness or more than 45 centimeters. Ang slab thickness na to is nata sa 125 mm or 12.5 centimeters. So i-multiply nimo na og 5, that is 625. So if 625 ka, inglapas na ka sa 45 cm. So this is not more than. Yeah, sakto. Shall be placed farther apart. Shall this reinforcement be placed? In no case shall this reinforcement be placed farther apart than 5 times the slab thickness or more than 45 cm. So, ilapas man siya sa ilapas man siya sa 45 cm nga maximum. So, you need to use 45 cm. So, nata example. So, this is the minimum ratio or reinforcement areas to concrete areas. So, ang atong isolve is ang spacing sa temperature bars. So, slab or plain bars are used. We will disregard the other we will just use a slab where deformed bars are used. Kaya ang atong gigamit nga mga kabilya dere are deformed bars. Karang nabitaw mga pintik-pintik. So, we don't use plain bars. We don't also use wire fabrics. So, we only use deformed bars. So, magamit lang sa ratio nga 0.0020. So, how to use this table? So, we have an example here, a concrete floor slab having a floor thickness of 10 cm is to be provided with number 10 deformed bars for shrinkage or temperature reinforcement. So, determine the spacing required. So, kinahanglan nato since kahibaw naman ta sa spacing nato sa ato ang bent bars and cut bars and your straight bars, di ba? So what we are going to determine is the spacing of the reinforcement bars. So sa question, gi-assume niya nga 10 number 10 or 10 mm ang deform bars nga gamit. So you just need to identify the spacing. So a concrete floor slab having a floor thickness of 10 cm is to be provided with number 10 mm deform bars for swing gauge temperature reinforcement. So determine the spacing required. So here's the solution. So find the cross-sectional area of a 30 cm strip of the slab. Katong ganiha nga gikuan na to, i-identify na to, butangan na to siya 30 cm. This is always our assumption, no? So 30 cm strip kay ano, mo man kay imong gi-considered as your inflection point. Mo man beam kintahay nimo ang i-consider sa imong slab, which is 30 cm from the face of your beam. So 30 cm strip of the slab, 10 cm thick. So nani ginote the 30 cm strip is used in designing slab. So this is mura na ni siya og constant na atong gigamit. So atong area is need to solve the area. 10 is your 10 cm thickness and your 30 cm nga strip ang iyang width. So natay 300 square centimeters. So refer to the table using deform bars, your value. So gagamit man ta sa balik to diri sa table 0.0020, we multiply na to sa 300 square centimeters. So ang may gawas na tong answer is 0.6 square cm. So mo ni area. Surface area sa to ang 30 cm strip. So this is the required area of steel bars. Required area of steel bars per 30 cm slab strip. So refer to the table. So sa to ang table, natay table dire. So nominal section, pila may nominal sectional area sa 10 mm, that is 0.7854. 0.7854. 0.7854 is square centimeters. So with the formula, 0.7854 times 30 cm over 0.6. So 0.7854 square centimeters times 30 cm over 0.6 square cm. So ang gawas na to is 39.27 centimeters. So mao ni siya ay spacing sa imong temperature bars. So therefore, 10 mm steel bars will be used as temperature bars spaced at 39 cm on center. So this value is less than 5 times the slab thickness. So remember mo, natay this value is less than 5 times slab thickness and the 45 centimeters limitation provided for the ACI code. So for example, mula pa siya sa akong ginikit ganiha. So kung mula pa siya sa 45 cm, we'll use 45 cm. But since wala siya mula pa, so we'll use 39. Okay? Kuha ra? Kakuha ra? Any questions?
Libog-libog pagamay, sir.
So asaman mga part kung kuhan? Asa mo nga part na confused? So, questions? Any concerns? Isa mo naglipog na part.
Magdip... Excuse me, sir. Magdepende ng 30 centimeter strip of the slab sa beam, sir.
Dili, constant lagi. Diba, ingon ko ninyo nga
Constant.
constant. 30 cm is constant. So, mo na siya imong gi-consider nga per 30 cm strip is used in designing slab. So, kani siya, during computation na siya sa temperature reinforcement. So, temperature bar reinforcement. Itong temperature bar, so constant na yung 30 cm strip. But, katong bent bars, ato ka magbase sa L over 5. So, don't be confused with the L over 5 sa imuhang 30 cm strip, ha. The 30 cm strip is constant in designing sa temperature reinforcement. But when comes sa imuhang bent bars, L over 5 yun ka. Okay, kani magong as per definition na itong balikan, ha. Itong balikan ang definition. So, one-way concrete slab is designed by making an imaginary strip of 12 inches or 30 cm wide perpendicular with the beam that supports the floor. Wide perpendicular with the beam that supports the floor. This imaginary strip is considered as a beam. Is applied where the width is equal to 0.30 meters and the depth is the thickness of the slab. The depth of the floor is purely dependent upon the span, the magnitude of the superimposed load. So kani mo na siya gigamit sa iyang designing. So imaginary strip. So ayaw ninyo i-appeal ang imaginary strip sa iyang band bars. So band bars is different from the imaginary strip nga 0.30 cm, 0.30 meters or 30 cm. So galibog mo sa computation.
Excuse me, sir. Asa ka nigikan ning 0.0020, sir? Na number 4?
Table A3. So
Yes,
mo na
okay.
siya imong minimum ratio or reinforcement areas to concrete areas. So you have to remember nga this is the minimum ratio for reinforcement areas to concrete areas. So mo na siya ratio sa imong rebars sa concrete. So you don't use plain bars, don't use wire fabric, only use deformed bars. So mo na gamit kag 0.00.
Sir, posible ka magpalabian o kadaghan ang bar? Posible
Sa ganito?
Posible ka nga mapalabian o kadaghan ang bar?
Unsay palabian kadaghan?
Nga maximum niya ba? Niya mo work against noon para sa integrity sa structure.
Mapalabian? Masobraan?
Yes, sir.
You mean, asa man dapita? Asa man nga side? Sa temperature, sa bend bars, straight bars?
Sa Benbar, sir.
That is the standard. That is the standard kuan. You mean kani? Madaghanan ra ang bend bars?
Unsa to, sir? Naputol ko.
Oo, kasabot sa imong question. Sobra na ang bend bars?
Yes, sir. Kaya ang
Ah,
equation
anong
nito
nakaingon mo? Anong nakaingon mo nga sobra ang bend bars?
hintay gidugangan niya ba? Murag ka
Hmm.
ng cleric ng error bitaw.
And then,
Posible ka nga ma-compromise no ng structure tungod dira.
if intentionally or if unintentional or whether intentional or unintentional, nama putay mga kuan. I don't think kuan kanang mga cause of failure kay during construction o magbutang ka og rebars, naman dyan na kuan, naman dyan na supervision. Makita dyan mo kung sobra ba or dili. Because you need to identify ang sari mga rebars nga mga ibutang. So you need to identify asa ang straight bars, asa ang bend bars, asa ang cut bars, asa ang temperature bars. So those are the four rebars nga should be present. So during construction, pahiluna gyud nimo asa unahon. Usually ang mauna gyud ani is ang straight bars. Yeah, mauna yung straight bars, hanay nimo na temperature bars perpendicular. So nakamating na siya. Naka-cross na siya, di ba? So if ma-identify na nimo ang pila ang imo unsay spacing sa imo temperature bars, so ibutang na nimo. Then after that, butang na nimo ang imo bend bars. So ibabaw sa ibabaw nga part diha sa inflection point nimo in between duha ka bend bars, butangan na nimo og cut bars. So kana ra, simple ra.
Excuse me, sir.
Mm.
Sir, na ito ko classmate nga reach out di ay regarding sa book. Sir, mo ni agkatong gi-recommend na mo pag niyagi, sir, nga book. At na mo makita ang kasagaran ng gitnang lesson ni mo discuss.
Sad to.
Katong building technology something tung katong mong gi-introduce ka na gi-recommend nga book pag last time, sir, nakalimut ko sa title kay actually wa po kong kapalit.
Simplified methods on building construction.
Okay. Mo na siya ni mong tigamit karon, sir, no?
Yes.
Discuss also na. Okay.
Mm.
Okay, sir. Thank you, sir.
So any questions? Any concerns?